Alrighty, so another video on the Git plumbing command series, and I'm so excited to take you through these also. So last time we looked into how we can write Git objects, and then shortly we mentioned that when a Git object is being created and stored, the process of creating it, the object itself is made up of two parts. That's the header and the content. And I promised that I'll briefly take you through how the creation of the object is done internally. So I'll manually show you, or we will manually create one for you to have a clear picture of what takes place underneath or under the hood. So I'm so excited to have this presentation today, and I hope you are all psyched to see what really happens, and to also take time and practice and play around with this. All right, so to start off, if you can have a clear, I have two terminals here. I've created two Git repos for the sake of comparing the two, so that we can compare the hash values. We can read, we'll create content and a header manually, and then we'll use Git plumbing tool also to create the same content, and then just compare to, for you to be able to see that the two are the same. So this is my first screen with the commit branch, and then the second one has the master branch, as you can see. All right, so to begin straight away without wasting a lot of time, we're going to use Ruby scripting language, because it makes it quite so easy to do the thing. We could as well use any other language like Python or any other scripting language to do the same, but for simplicity reasons, we are picking Ruby here today. So yeah, so first of all, so I'll just fire up Ruby, and you have to ensure that you have Ruby installed in your machine, and try to see if you can run the Ruby interactive shell. If not, please ensure that is in place if you want to follow along. So I have started Ruby, and as you can see, there we have it. So the first thing is we normally create content. Remember the other time we used to create content by use of the echo command, and then we do the content, our content, and then we pipe it through some we pipe this, and we pipe it through some other command, which was git hash object, if I can remember. And then there was write, okay, and then there was something like standard input, something like that. So we pass it through, we collect the standard input, which is the content we have. We pass it through the hash object, and it creates an object for us and stores it into the Git file and within the objects database. But today we are going to do things a little bit differently. So we are manually going to create the content. So we'll create a variable, let's call it a content variable, and within here we want our content to be similar on the because we are going to compare the two. So yeah, so I'll say just something so maybe I'll say why learn. Our content will be as simple as why learn Git anyway. Let it be like a question. So we'll use the same on the other side. And then what follows after this is so we have, so if we call the content variable, it contains that line why learn Git anyway, and then we'll create a header. What Git actually, this is what Git does. So you create content, and then Git normally under the hood it creates the header, and when it creates the header, it normally within the header, first of all, it has to identify what sort of data you are trying to store. So it has to identify it first. So in most cases, Git handles blobs. So it has to, the first thing within the header is to identify the type of data. So it will identify it as blob. Okay, so so here we are creating the header, the other side. So we create header. So so we'll create a variable called header, and then within this variable, what we're going to, the first thing, as I mentioned, is the type of content. In this case, it's a blob. So this is how it stores. It actually identifies the type of a content. Is it a blob? Is it whatever it is? So it has to notify. It has to store that, and then the next thing after the type of the content you're trying to store within the Git database object, what follows closely after that is the size of the content you have. So we have to identify the size of our content. So for that, for us to be able to do that using Ruby, we just call the content variable, and then we call the byte size. Am I typing that right? Yeah, byte size. So this one will give us the size of the content you're trying to store to the Git database. And the first bit is the type, and then the content size, and we always close that with the null bytes. So we are closing the sentence for that case, so using a null byte. Yeah, so we have a blob, and the type, which is the blob, and the size, which is you can see it's 21. All right, so we have the size, and so that's the header. And the next thing is to concatenate, or to put together the header and the content. So this is the process that Git always takes. So after having the content, creating the header, the next thing is to do the concatenation, or to add together. So we are going to concatenate the header. I don't know if I've written that correctly, but whatever. So we are going to put the header and the content together. So we'll create another variable to make it so easy. So we'll create another variable, maybe let's call it store. And then within the store variable, what we're going to do is we're going to put together the header and the content. And then that will be ready now to be passed through a SHA1 digest to come up with the hash value. So this is what we're going to do. So we are going to create a variable called store. You can call it whatever you want, and then we just like put the header and the content. We merge the two. So right, I hope everything is correct. Yeah, so there we have, as you can see, the new sentence, or the new content is we have the header merged with the content. So we have the blob 21 blah blah, and then while and it anyway. So up to there, I think we are doing fine. And then now the next thing is we're going to require the SHA1 digest, the one that we'll use to create the SHA1 value or hash value. So we'll need that a library or module for that case. So we'll require, so for with Ruby, you just use require to like call the libraries you want to use. So in this case, we want to use the digest library, and the one that handles SHA1 algorithm. All right, so we call that. So if you see true, that means we have it. And then so the next thing is let's now pass our header and content, the store variable. Let's pass it through the SHA1 digest, hex digest, and then get the SHA1 hash value. So that simply will say we'll create a variable again called SHA1 for ease of handling everything we are doing, and then we'll call the digest module, and then from there we'll call the SHA1, and yeah, hex digest, and then we'll pass in the store thing. right? So yeah, so there we are. So what you can see is you can see now we have the hash, the SHA1 hash value, and later on, if we call the git cat file and pretty print and we pass in the hash value, you will be able to read the contents, the content of this object. So this the hash1 value, and the next thing that happens after this actually is that this is not just stored the way it is, but it has to be zipped for the sake of minimizing on space, of not wasting a lot of space. This content is always zipped, so we'll zip it later on, but at the moment what you're going to do is we're going to move to the other terminal, and we're going to create the same. Now we've created this one manually, but we're going to now use the git plumbing command to do the same, but that is just a one-liner, so we won't go into so many steps. What we'll need is this content, so I'll just like copy this, and I already initialized git plumbing 2. This was git plumbing 1, and you have to take note of the SHA1 value. So we'll move to the next terminal, and what I'm gonna do is so quick fast, let me see what I'm going to do here. So I'm going to use the echo command. So I'll call echo, and so just to ensure that we don't have a formation of one. You remember on the other side we had a null byte that used to close a line. Tell the yes, it is important, because if you don't close a line, then we are going to hash empty space. We don't want to do that. So in this case, we'll use echo. We pass in a flag of n just to tell to notify that we are not going to entertain new lines. So the end of the content is the end. It's like creating a null byte. So, and then we are going to have the same content. We head the other side, and then we're going to pipe it through git hash object that creates the object. So right, so going to pass it through git hash object, and we're going to, of course, read the value, and then we're going to compare the two hashes. They have to be the same. So, and there we have our hash value. So with this hash values, you don't need to like memorize everything, because it is 40 characters, but you just have the first 5, you're good. So our first 5, we have 70751 F. So if we move to the other side, we also have 70751F. That means these hash values are the same. They are similar. So the content we have this side is similar to whatever we have this side. So this side, remember, this is the header plus the content. And so this side also, the git hash object, that the plumbing command that is used to generate the hash value for the object, also created a similar hash value that is a combination of the header and the content. So you see the two are similar. So although this side we went the manual way, and we followed, we took it was quite a marathon, but we arrived at the same thing. Yep. Okay, for some reason I forgot to write the content, so I just like did echo, and I've called the hash object command without passing in the right flag. You can see right here. So I had to do that again, and because if you don't do that, then when you're trying to find the object, you won't be able to get the object. So right now, if we use the find command and we try to find the content of the object, we'll be able to identify the object within the database. So simply put, if you don't write, then you are not storing the object that you've just created into the database. So for this case, if we do this, we check into the git object. Then we are able to see the content. So if we cut the file, to see the content of the file, then we should be able to see similar content to what we just echoed. So we shall just do that right away for it to have a clear picture of what you're talking about. So we'll use the git-cat file, and then we pass in the object. We're not going to copy the whole hash value, but we'll just like go with the first 5. So I'll just pick the first 5 characters. Let's go to the F. Oh, I forgot something. You have to pass in the type. Remember, we have the size, the type for flag. The one with the flag of T is the type. The flag of S is size, and yeah, E for exit, and then P for print, pretty print. So we have to pass in that. Sorry. Yeah, and there we have our content. So this is on this other side, and then to replicate the similar thing with the Ruby command, we have also to write our content. If we don't write our content, then we are not going also to be able to identify the object. Right now, this object just exists within its existence is volatile in nature. That means it is not stored anywhere. It's just hanging. So let's write it. Sorry if you can hear some noise. I think there's nothing I can do about my neighbors. They have just to do what they do. Just ignore them. Okay, so we had the hash value, and what we had to do from here was to create a path and then to write that into a file, and then we see if we can get the same object and be able to like read from it. So I'll just do that quick first because I think yeah, so let's do that. So first of all, with this we are going to zip the content, and to zip the content require a zip library. So we'll just like get that one right away. It's a zlib library. So we got that, and then the next thing is we'll store the zipped content into some sort of variable. So we can call it zipped content. And then what we're going to do is we'll just like call the zlib and then pass in the content. So the content we called it store. Now we got it, and then the next thing is we'll have to create a path for the new file that we'll create from the hashed object and the file itself. So to do that, just create like a path. We'll use a path variable, and yeah, hope you can hear me loud and clear. So if you can't hear me properly, you just like leave that one in the comment section, and then I'll see what to do about it, but you should be able to hear me properly. So what you're doing here is remember when we initialize Git, we have this .git, and within that we have the objects folder where we handle like the storage of the all objects we create. So what you're doing here, we are using slicing to like slice the SHA1 hash value. You can see what we have here. So we yeah, we are and then we have an issue here even before we go any further, because you remember the first there's a change in letter. Here we have a small w, and in the other one we had a capital W. So this one gives us a different hash value from what we have on this other side, because what we have here, the hash value we have is 7070, and we had a capital W. So a change in letters, small letter or capital letter, matters. So we'll have to, I think we'll have to rectify that before we move on. Actually, if not, then we did we have that here. Okay, so there's a confusion between the two. So you just note that I actually did change that, because here we have capital W. So it's a good thing also. You get also to learn something about it. Okay, fine. So we have the path and a path variable, and what we're going to do, we were doing the slicing right away. So sorry for taking you back. This one to save on time also. Don't want this one to take too long. Okay, right. So we'll call the SHA1, and we slice the first two characters to form the folder. But there's one thing we are forgetting, is this slash. If not, it will put everything together. So we have the first two to form the folder, and remember, after that folder we'll have to pass in a slash also, the Unix way. If it was Windows, then the folder will have not a forward slash but a backward slash, and then we pick the rest of the characters, that is from the second one to the last one. Yeah, and that one will form the file name. So there we have it. I think when you look at it, it's correct. And then from there, so we'll use this path to create now the real folder. We haven't created it, but we just have the path. So why not create the folder itself and the file, and write the contents of the zipped the zipped object into the file. So to do that, we'll use the file utils that exists within the Ruby language, the shell. So so let's require the file utils. So anyway, it's not going through, but it does exist, so I'll just like use it direct away. I don't think if there is any problem with that. So okay, so there it is. Then we pass in the path, so it will create the directory. With this, it will create the directory. So there it is. And then okay, so we have the directory. So the next thing is let's open the file and write in the content. So to do that, we will we'll use the file module and call the open function, and then just pass in the path. And then we don't forget to like write. If you don't write, then you will not get your contents. So we have a function. So we'll create an object, and we'll use the f object, the file as a f.write. So we'll write into that file. and what you're writing is zipped content. So there we have it. Yeah. So basically what's supposed to happen from this point onwards is we're supposed to have this content within the Git file. So if we go and check within the Git, within our Git directory, we're supposed to have the contents of this hashed object, the folder and the file, and then within it we're supposed to have the zipped content within it. So if we cut that file, then we're supposed to be able to read the exact content we entered. So we shall just exit. So we're actually supposed to get the same. So if we do git cut file p and then we read, supposed to get the similar content to this. So let's see. So we'll have to exit and then use git command to like find out whether our stuff is correctly done or not. So let's just exit. Okay, so let's see if we can find what we just created. Objects. Yeah, so here it is, which is a good thing. So from here, what you're going to do is we'll just use git cut file and then pass in the pretty option and then pass in the 7075 forever hash value 751 F. And you can see we have the contents of we have our contents why learn git. So that's it. So as you can see, we went the manual way, but at the end of the day we got the same results. And with git it was just as simple as using the git hash object, and then you remember to write and then pass in whatever whatever you are getting from the terminal, whatever input, the standard input. This one is this flag is used to like read whatever input you are trying to pass from the terminal and then write it into the object. So the same thing we did with a one-liner command, we've done it manually, and you can see it is quite a process. So basically what happens under the hood is this is what git does. This is the whole process it goes through. Yeah, it creates a header, and you remember the header, it has to identify the type of content. The header identifies the type of content plus the size of the content. That's what the header has, and then it merges the header and the real content now, and then from there it passes it through a hash digest using SHA1. It creates that hash value. Using that hash value, it creates the folder where it's going to store. So for every content, for every other object you create or any other commit you do, every commit you do using Git, it always does create a directory for it and a file to store it using the hash value that it gets from merging the from concatenating the header and the content. And then from there, after creating the hash value, what it does, it does zip the content. I told you the importance of that is to minimize on space. And then after it has zipped the content, it will write the zipped content into the file that it would have created. And so for it to create the directory and the file, it uses the file libraries and the folders to create that, and then it writes the content. And yeah, so when you do the git log, you're able to like log these hashed values, and then you can even read the content of each log. So, and we simply did that using the git cat file to read the content. So up to there, I think that's all for today, and let's prepare for the next one, where we'll be looking at the tree. I thought this one was quite important to come before the tree objects, so we'll look into the tree objects and then move on from there. Otherwise, thanks for your patience and for following through, and I've also been able to experience an increase in terms of the subscribers. So if you've not subscribed and you're watching this, please remember to subscribe and support our channel. And yeah, so we are glad to have all of you on board. And if you feel that this content is quite important and there's someone who will someone else who will benefit from it, please feel free to share. Otherwise, see you next time. Thank you. Bye.